Imagine floating silently through the space. The stars shine around you, galaxies stretch across the darkness, the universe appears peaceful. Then suddenly something strange happens. A distant star begins to bend, light itself gets curved, time seems to be slow, and ahead of you lies something completely invisible. You cannot see it, you cannot touch it, yet it controls everything around it. This is a black hole, an object so powerful that even light, the fastest thing in existence, cannot escape its grip. For decades, black holes have fascinated scientists, inspired movies, terrified astronauts, and challenged our understanding of reality itself. But what are they really? Are they cosmic monsters, gateways to another universe, nature's ultimate destroyers, or something even stranger? Today, we begin one of the greatest journeys in science as we uncover the truth about black holes. Throughout history, humanity has repeatedly discovered that reality is stranger than imagination. People once believed Earth was the center of everything. Then we learned Earth orbits the sun. Later, we discovered the Sun is just one ordinary star among hundreds of billions. Then we found galaxies, then billions of galaxies. Each discovery made us realize how little we truly knew. Black holes represent the next chapter in that history. They force scientists to confront questions that seemed impossible. Can time slow down? Can space tear apart? Can information disappear forever? Can the universe itself break its own rules? The deeper scientists investigate black holes, the more mysterious reality becomes. To understand black holes, we must travel back centuries. Before modern science, gravity was viewed as a small force. Things fell because Earth pulled them down. Planets orbited because the sun pulled them inward. Then came Isaac Newton. Newton's equations revolutionized the science. For over 200 years, his laws accurately predicted planetary motion. Yet one question remained unanswered. What exactly is the gravity? How does it work? How does the sun influence Earth across millions of kilometers of empty space? No one knew. The answer would come from a man whose ideas would completely transform the physics. In 1915, Albert Einstein introduced general relativity. The idea was astonishing. Gravity was not really a force. Instead, massive objects bend space and the time. Imagine placing a bowling ball on a trampoline. The surface bends, smaller objects roll towards it. Einstein proposed that stars, planets and galaxies do exactly this, except they bend space-time itself. Earth orbits the sun not because it is being pulled. It follows a curved path. through distorted spacetime. This concept changed everything, and hidden within Einstein's equations was a terrifying possibility. If enough mass were squeezed together, spacetime could collapse entirely. Only months after Einstein published his theory, a German physicist named Karl Schwarzschild found something extraordinary. He discovered a mathematical solution suggesting an object could become so dense that space-time would collapse around it. The prediction sounded absurd. Scientists largely ignored it, and after all, what object could possibly become that dense? The idea remained a curiosity for the decades. Then astronomers began studying the massive stars, and suddenly the impossible became inevitable. Every star lives a life. Stars are born from enormous clouds of gases. Gravity pulls the gas inward. Pressure increases, temperature rises. Eventually, nuclear fusion begins. A star is born. For millions or billions of years, the star balances two forces. Gravity pulls inward, fusion pushes it outward. The battle continues peacefully, but every star eventually runs out of fuel, and when it does, the gravity wins. When extremely massive stars reach the end of their life, something catastrophic happens. Fusion stops, the outward pressure disappears, the entire star collapses inward. Imagine compressing Mount Everest into a grain of sand. Now imagine compressing millions of Earths into something smaller than a city. The collapse happens within seconds. Temperatures rises into the billions. Then comes one of the nature's greatest explosions, a supernova. For a brief moment, the dying star can outshine an entire galaxy, and from its ashes, a black hole may get emerged. After the explosion, the remaining core continues collapsing. Gravity becomes stronger, matter becomes denser. The collapse accelerates. Eventually, a critical boundary is crossed. At that moment, escape becomes impossible. Not even light can leave. A black hole is born. It is not an explosion. It is not a hole in the space. It is a region where gravity dominates the reality itself. The event horizon is often called the point of no return. Imagine standing beside the most powerful waterfall imaginable. Far away, escape is easy. Closer, the current becomes stronger. Eventually, there comes a point where no boat can escape. The event horizon works similarly. Crossing it means entering a region where every possible path leads inward. Nothing can return, no, not matter, not light, not information, at least according to our current understanding. One of the greatest mysteries in science begins here. Nobody has ever observed the inside of a black hole, nor can they. Any information crossing the horizon disappears from our view forever. To an outside observer, the interior is hidden. It becomes one of nature's most secure secrets. Yet, mathematics suggests that deeper inside lies something even stranger, the singularity. Singularity represents the ultimate breakdown of physics. According to general relativity, all the mass collapses into an infinitely small point, infinite density, infinite curvature, infinite gravity. So, whenever infinites appear in physics, scientists become suspicious. Most researchers believe the singularity does not truly exist. Instead, it signals that our current theories are incomplete. A deeper theory remains undiscovered. Surprisingly, black holes are among the brightest objects in the universe, not because the hole itself glows, but because material surrounding it becomes incredibly hot. Gas spirals inward at near light speed. Friction generates enormous temperatures. The result is an accretion disk brighter than entire galaxies. Ironically, one of the darkest objects in existence can create some of the brightest light in the cosmos. For decades, the black holes remained invisible. Scientists could only infer their existence. Then humanity achieved something extraordinary. In 2019, a global network of telescopes effectively turned Earth itself into a giant camera. The result was historic. For the first time, humanity saw the shadow of a black hole. A prediction made more than a century earlier was confirmed. The image became one of the greatest achievements in the scientific history. One of Einstein's strangest predictions involves the time itself. Gravity affects the clocks. The stronger the gravity, the slower time passes. Near a black hole, the effect becomes dramatic. A person orbiting near a supermassive black hole might experience only hours, while decades pass elsewhere. This is not science fiction, it is real physics. Black holes transform time from an absolute concept into something flexible. Movie Interstellar captivated audiences because much of its science was surprisingly accurate. Physicist Kip Thorne helped ensure realism. The black hole Gargantua demonstrated genuine time dilation effects when astronauts visited a planet near the black hole. Hours passed for them while years passed for people far away. The film introduced millions to one of the strangest consequences of general relativity. Imagine stretching a rubber band. Now imagine gravity stretching an entire human body. Near certain black holes, your feet would experience stronger gravity than your head. The difference becomes enormous. The body elongates. So scientists call this as spaghettification. While the term sounds amusing, it reveals the terrifying strengths of tidal forces near the black holes. Most black holes form from dying stars, but supermassive black holes are different. They contain millions or billions of solar masses. Every major galaxy appears to contain one, including ours. How these giants formed remains one of astronomy's biggest mysteries. Some may have grown from smaller black holes, others may have formed directly in the early universe. Scientists continue searching for the answers. Hidden at the center of the Milky Way, like Sagittarius A, we can't see it directly, yet its presence is undeniable. Astronomers observed stars orbiting an invisible object at incredible speeds. Only a supermassive black hole could explain such motion. For decades, scientists tracked these old stars. Their observations eventually earned a Nobel Prize. Stephen Hawking transformed black hole physics forever. Using a quantum mechanics, he proposed something astonishing. Black holes are not completely black. They emit tiny amounts of radiation over immense timescales. This radiation causes them to lose the mass. Eventually, they may evaporate completely. The idea connected gravity, quantum mechanics, and thermodynamics, three of the greatest pillars of modern physics. Then a problem emerged. Quantum mechanics says information cannot be destroyed, yet black holes seems to erase information forever. This contradiction became known as the information paradox. For decades, some of the world's smartest scientists have debated the solution. Many believe resolving this mystery could unlock the long short theory of quantum gravity. Science fiction loves wormholes, shortcuts connecting distant parts of the universe. Some equations suggest wormholes might theoretically exist. However, no evidence supports their existence. For now, they remain speculative, yet they remind us that black holes still hold countless secrets. Some black holes defy imagination. Ton 618 contains tens of billions of solar masses. Its event horizon is larger than entire solar systems. Objects like Ton 618 challenge existing models of the cosmic growth. How could something become so enormous? Scientists still do not know. Some researchers believe black holes may help explain the birth of the universe itself. Others speculate our universe could exist inside a black hole. These ideas remain controversial, yet they illustrate how black holes connect to the deeper questions imaginable. Why does the universe exist? Where did it come from? And what lies beyond observable reality? Many myths surround the black holes. Not they do not roam the universe, swallowing everything. No, Earth is not about to be consumed by one. No, scientists are not creating dangerous black holes that threaten humanity. Evidences and observations remain the foundation of science. Separating fact from friction is essential. Black holes teach humility. They remind us how little we know. They inspire innovation. They challenge assumptions. Most importantly, they demonstrate that curiosity remains humanity's greatest strength. Every major discovery began with someone asking a question. Black holes are not merely cosmic monsters hidden in the darkness. They are laboratories where nature reveals its deepest secrets. They challenge our understanding of gravity, time, space, and reality itself. The truth about black holes is not that they answer every question, it is that they create new questions. And perhaps that is their greatest gift. As long as mysteries remain, humanity will continue exploring, looking upward, searching farther, dreaming bigger, because somewhere in the darkness, beyond the reach of light, lies the next great discovery waiting to be found. Thank you for joining this journey through one of the greatest mysteries of the universe.